Hello, hi, this is Ravindra Goduru. This is my big data course term project, Formula 1 dataset, and here I am discussing about the Formula 1 race and its data and how it is going to be analyzed using the big data and Hadoop technologies. Here I just want to give you a brief introduction about the Formula 1 race. Formula 1 is the highest class of single-seater auto racer sanctioned by FIA and owned by a Formula 1 group. This is the actual definition given from the Wikipedia. The F1 race is based on the single-seater automobiles. The dataset is taken from the Kaggle.com, and this dataset has around 10 to 12 CSV files which gives all the data about the Formula 1 data. Here to discuss about the 4 V's of big data: the volume, variety, velocity and veracity. All these V's are satisfied in this dataset, hence this is apt for the analysis of big data technology. Here in this slide I am depicting the main features such as circuits, which are 73, the races, which are 1009. The circuits is the small part over here, and the races is the big half, not half, less than half. And next one is the constructors, and then drivers also takes most of the pie, and the last one is seasons of 70 seasons. This data set is comprising of data starting from 1950, on which the first Formula 1 race was started, till 2017. So it almost covered all the data of each and every race. Coming to the other properties of the Formula 1 data set, like pit stops, driver standings, constructor standings, results of the constructors and the results of the races. Each and every data is depicted here in this bar graph. And coming to the work of our project, here I am taking the two major problem statements of this data set. From this data set, first to find out the top driver in a particular race, and the second one is the top constructor in this particular race. There are around 1009 races, so to find out just one of the races on the top one in that race is going to be a hurdle for normal relational databases. And here in our project, the technologies which I am showing for the first problem set is Hive, Spark and the BigQuery, and the second one is Hive, MapReduce, Spark and BigQuery. The overview of the first problem set. Here I need to get these are the attributes of races. Race ID is the attribute in races. Race ID, driver ID, position and everything are the other attributes from result, and in the same way driver ID, driver name and are the attributes from drivers. Here from the race ID, which is given as the input, we are finding out the race ID from the results CSV file, and from there regarding the position, which is a key value, and we will get the driver ID from the results. From the driver ID we get the driver name from the driver's CSV file. This is the flow of the procedure to find out the top driver from the race ID. In the same way, we are going to find out the top constructor in a particular race. we get the race ID from the races, and from the constructor results we get the race ID, constructor ID points, and constructor ID and constructor name from the constructors. From the points as a key value, key point, we get the constructor ID as the value. From the race ID, which is an input to the code, we get the race ID to the constructor results, and from the calculated points in the CSV file of constructor results we get the constructor ID. From there, the constructor ID, we get the constructor name from the constructor's CSV file. Thus we find out the top constructor in a particular race. If we see, this is the Hive code. Here the input value which given to the Hive is like this. It's a select statement. From the driver ID, phone name, surname, we need to get all these parameters. From the race ID 1, we are selecting the top racer from the race ID 1, so we get the top racer from the race ID 1 is the driver ID with 18 driver ID, and his phone name and the surname is Jensen Butson, and it took 86 seconds to finish all the Hive programs in the background. Coming to the second Hive program, we are finding out the top constructor from the race ID 18. From this race ID we got the constructor ID 1 as the top constructor, and its name is McLaren with the position 1, and it took 70.311 seconds. Thus we find out the top constructor in the whole CSV whole data set. In the same way, we took MapReduce to find out the top constructor in the race. Here the race ID is the 25. This is the input value which is given to the MapReduce code, and we see the map and reduce functions completing the 100%, and out the race ID 25 we get 6. The constructor ID is the top constructor in the race of race ID 25 with 18 points. Thus completes the thus we get the Hive and MapReduce codes. Here if you see 6 constructor ID is the Ferrari is the top constructor in the race ID 25. In the same way, we see the BigQuery. Here we give the GCP values, where BD102080 is the instance of GCP and Ravi 011 is the project name. That's all. And from here we can conclude that the thousands and lakhs of data of this Formula 1 race can be analyzed using the big data and Hadoop technologies, the MapReduce, Hive, Spark and BigQuery. The Spark cannot be shown here because of the environment issues, and we can get the best results from Spark and BigQuery, as these are the advanced technologies to analyze the big data, whereas MapReduce is an old technology to find out the analyze the data of big huge data sets. Thank you.